This tutorial video is meant to go over what criteria to evaluate when deciding whether you can rerun a tool or not. Throughout this video, we'll go over a certain checklist, and that checklist covers our post-run information, so what happened during the run. We'll include a brief component overview for terminology and placement on the tool, and then what to physically check once the tool is on surface. We'll talk about different scenarios between runs and how the bit grade can ultimately affect whether you rerun the tool or not. So our main tool when evaluating whether we should rerun or not is this rerun criteria checklist. It's available on InTouch ID 6455313. So this is an organized macro set up with predetermined selections. Based on what you pick, it'll tell you if you should rerun, proceed with caution, or you should not rerun the tool. So we'll start at the top with power drive orbit was reason for pulling out a hole. So this one's a no-brainer. If you select yes here, you can go ahead and omit the rest of this criteria. The next one is your real-time data indicating orbit. Another yes or no that you can stop the process depending on your selection, but the real-time data that it's asking for is your RT stat. Is that signaling failure alarms? Your tool face desired minus actual. This is basically is your green and red arrow separating. Another thing you can look at is your steering ratio desired not meeting the effective. So is your tool having trouble giving you the desired steering ratio? And then obviously if you're having directional response, you're not meeting your HIA targets or your ink hold targets. Next is looking at the severity of your shocks and stick slip. Your option for shocks here goes from no shock all the way to level 3, level 3 being the most severe. And this is a judgment call, and you're looking at a sustained amount of time, at least like 30 minutes. We're not looking at just one peak value of level 3, but if you're sustaining level 3s for most of the run, you can go ahead and select here. Max temperature is just asking which side of 125°C you're on, less than or above. Was your tool subject to jarring or rotation without circulation? Total pump hours broken down into 4 different options, all the way from less than 30 to over 100. You have your average bit RPM. If you notice, it says bit RPM and not surface, so this would be your surface plus the output of your motor based on your flow rate. Row 22 is very important, which is your ditch magnets. Were they present? Were they regularly monitored and cleaned? So the rule of thumb here is monitor and clean your ditch magnets every 6 hours, so twice a tower. And a yes or no is determined here. Do you think a lot of metallic flake got past your ditch magnets or not? Because they can attract to the magnets on the tool and cause for steering issues. Last on your post-run information is the motor stalling at the end of the run. So basically it's asking, is there a possibility that there's rubber chunks in the internals of your power drive? Yes or no? So our next section is focusing on, once we're on surface, the physical checks for the tool. So before we dive into this section, let's take a look at the breakdown of the different components for different collar sizes.
Here functionally, upper and lower kickers. This is the pad. This is a clamp plate. Inside the clamp plate is the hinge pin, which holds the piston in place and lets it pivot. And those are the main components that you'll see on the outside. So if you need to identify them, kicker, clamp plate, pad, kicker, and then hinge pin is inside, which is a pin, and then kicker bolts, which are the bolts here that hold it all together under the assembly. So for comparison, this is an orbit tool. Usually there's duct tape wrapped around it because these pads are more loose than an X6 tool is. But you can see the two rounded sections here that are the two pistons with the carbide sleeve and the carbide ball inside. Same thing, kicker, pad, clamp plate, and upper kicker. So you'll have three major components. You'll have the bias unit, which ends, then you'll have an extension sub here, and that just mates these two pieces together. So a 475 collar is slightly different. This is a 475 stabilized collar. These are the anchor bolts. This is the ABFT design, which is a slightly bigger bolt than the old version. You should only see these big bolts on collars. Let somebody know if you see a bolt that's smaller than this. You have stator bolts. So this retains the stator that goes over the impeller on the ID of the collar. There's a bolt here, and then 100 degrees out, a bolt here. So those are stator bolts, closest to the anchor bolts on the lower end. You again have collar magnets. So these are simply magnets that let the control unit know how fast it's spinning relative to the collar. You got one here, one here. That's mid-body on the control collar. This is the Acme thread upset. You'll normally see a sleeve stabilizer or a slick sleeve on top of this, and you'll never see that thread, but it's just good to inspect all that. That could be cracked. You'll see these are the upper anchor bolt holes. There will occasionally be another set of ports above it. You can see that we filled these in. These would be for the real-time float, but now has eliminated those holes, so you might see them on a couple of collars, but for the most part they'll either be filled in or missing. So the upper set is real-time float, the lower set is the anchor bolts that hold the. So this is a 525 power drive collar, which instead of being 475 has an upset. You can see how it gets slightly bigger here on the OD. And it uses larger bolts that go inside. So this is, if you've ever seen the 45-degree cracking that happens on the collars, this upset is designed to make this part of the connection stronger, this part of the collar stronger. It doesn't have the real-time float bolts at all on these 525 collars. So these are the upper hanger bolts. Collar magnets here. Again, the upset to 5 1/4. Lower stator bolts, lower anchor bolts. So portholes on a 675 collar. The lower anchor bolts closest to the bias unit. Collar magnet, which is not a bolt, it's just a little magnet that installs here, and then you have one 90 degrees out of phase on the other side. I'm sorry, 100 degrees out of phase on the other side, 180. If you notice a hole in a sleeve or a sleeve stabilizer, if it weeps mud from here or from a hole that's drilled somewhere around here, that's intended to be there. It's a small pressure equalization hole. So if you see a small hole, this one doesn't have one, of course. If you see that small groove, that's normal. And that small hole, that's normal. That's to equalize the pressure on that thread to make it easier and not store pressure. Upper anchor bolts. Those are the last two bolts on the 675 collar.
Now that we have a good background knowledge of the different components and where they're located on the tool, let's go through each physical check and what to look for. So the first one is worried about our pad wear. So very important check here. And if you go on InTouch, you can see a grade evaluation sheet, InTouch ID 5569788. So this is how we would grade our different pads. So if there's this is basically mint condition pads. You don't see the tile or button inserts for hardness protection. There's no wear on the edges or the middle of the pad. Grade 2, you're starting to see some of the tiles for your hardness protection, which is normal. This is still not severe at all, and there's no wear on the edges of the pad. So grade 3, a little more severe. You're starting to see grooves around these tiles, minimal pad wear on the edges. And then grade 4, this is your worst grade, so the most damaged. And I would have excessive damage on the edges. You have missing inserts, and the grooves are pretty deep around the pad. So this is basically your DBR pad. So select what grade you have there based on your drop-down box. Next one is looking at if there's cracks on your bias unit. So you want to make sure and wipe down your bias unit all the way around. Check for cracks. Actuating the pads open and close. So this one, if you'll notice here, you should be able to actuate these pads by hand. And they should only move in one axial direction around that hinge pin. So if there's side-to-side play, you probably don't want to rerun that tool. And also, when you're opening the pad, if you've compressed it all the way down, you might need a small screwdriver just to pry it open because it creates somewhat of a vacuum underneath. You shouldn't need to really put out on this pad, just some sort of leverage to get you started, and then after that you should be able to move it by hand. Next is your hinge pin broken. So this is asking about that side-to-side play, or if there's a lot of jiggle in that pad. It should just open and close in one direction perpendicular to the body of the tool. Next, it's good practice once you break the bit off to remove your flow restrictor body. And this is asking if there's erosion. So you want to check your O-rings, you want to check if there's wash on the outside or the ID of the restrictor, and then fill out your box accordingly. So does it have signs of erosion? Yes or no? Anchor bolts present. So if the collar is going to crack, usually it will initiate around these anchor bolts or portholes. As you can see here, there's hairline cracks. So you want to check your bottom two, your top two anchor bolts, and then the collar magnets and stator bolts on the mid body. You want to wipe down these and check by hand each one because they could be small hairline cracks that are starting to propagate. Next here is your control collar stabilizer. You want to check to make sure it's gauged because this is your third point of contact in your fulcrum. And a gauge here is very important to rotary steerable steering. And then it's asking if it's not excessively worn. So yes would mean it is not excessively worn here. You can see here there are some components of erosion. Since these stabilizers or a sleeve, they are handled in the shop, and if they are dropped, you could see little damages like this. So if you see this, you probably don't want to rerun the tool. The last physical check is recommending that you do a post-run surface test. This is not always done and will be touched on in another video. Let's just put yes for now. Then once we're done with our physical checks, in the situation where we plan on racking the tool back, it's asking if it's going to be racked back for over 24 hours. Good recommendation here that if you are going to rack it back, to attempt to flush the tool out with fresh water best you can before racking it back. And then the last recommendation is if you're in sub-freezing temperatures, sub-zero, just like any other tool, if there is moisture, if there is fluid in it, you want to keep it either on the rig floor or under a chinook, somewhere where it doesn't get below freezing due to the small integral parts inside the tool could be damaged. Lastly, looking at the next run, with your cumulative hours plus what your expected run length is on the next one, you want to take that into account. There's no hard number here. At X amount of hours, you shouldn't rerun the tool, but above 100 circulating hours, there's more chances that you have wash within your impellers or something damaged within the tool. So case-by-case judgment here. Select as needed. Also a good reminder, your flow rates and mud weights, if they're different from the previous run, you might need to revisit your PD squared and reset up your hydraulics based on what restrictor you're running. If not, if everything's supposed to be the same, then that's a yes here. And at this point you can see we can rerun this tool. If you use one of these options, your other option is proceed with caution, and then most of these yes or no's upon which your selection is will trigger tool should not be rerun. Alright, in summary, whenever you're deciding whether to rerun the tool, this checklist is not definitive. It's just a good start to evaluate all the criteria and have an educated conversation with whoever is involved in the decision. Remember, when you're checking, the only exception to tripping for a steering problem is if everything checks out but your gauge cutters are DVR'd on your bit. This could affect why you weren't getting the correct steering response. So that's the only exception that you might want to rerun the tool if you trip for directional response. Remember, if there's a potential for debris in the tool that could jam and affect your steering, you don't want to rerun it. So that's LCM, potential rubber or metallic particles in the tool. Physical checks, remember checking your pads, checking the play on the pads and the damage on the edges or the lower kicker. Your stabilizer, make sure there's no erosion spots. Make sure that that stabilizer is engaged because that is the third point of contact for your steering fulcrum. And then remember there's 8 portholes on there. Make sure that the bolts are in them and that there is no hairline cracks along the edges since this is a high stress concentration area. So that concludes this video.